Hi, today we'll be looking at the Modbus I Flash software. The Modbus I Flash software is what DataNab uses or provides our customers to use in order to program our programmable I/O devices. First we'll start off with explaining how you can get the I/O Flash software from the website, and then we'll go into how to program one of our devices with it, and hopefully this will give you a good handle on how to get started with that, so you can start playing around and get comfortable with the software for your own purposes. So if I look up here, it's because I'm looking at the screen while I'm going through this video. If you go to datanab.com, as shown here on the screen, and go to support and downloads, you can click on main browsable document and directory, click on the Modbus I/O folder here, and then the Modbus I/O Flash folder. And what you'll see in this folder is a number of exe files. There's a pro version, which costs $495, and then there's a free version, which is free. The only difference is the pro version, the program sizes can be about twice as large, and there's some extra function blocks available to do some special items in there. Most customers get along with the free version, okay. If you decide you want to use the pro version, you can download it for free and try it out. It runs for 10 minutes at a time, so you can take a look at it and decide if it's got things in there that you might want to use. And if you do decide you want to purchase it, just let us know. It's $495. And for this demo, we'll be using the pro version. So if you wanted to do that, you would click on this exe file, download it to your computer, and then double click on it and run it, which would install the software. Once you've got it installed, you would see in your C drive, as shown here in Windows Explorer, you'd see a folder called Modbus I Flash or Modbus I Flash Pro, depending on which version you installed. You can see here I've got a couple different versions of the Pro installed. For this demo, we'll be using version 270. 270 is not on the website right now, as you can see down here, but by the time you see this video, it probably will be. So you click on the directory of the one that you had installed it to, and then there's an exe file in there, Modbus I Flash ccpro.exe. And that's what you double click on in order to open up the software. Okay, so once you've done that, this is what you'll see, a window like this. It'll just be an empty window. In this window, you can see that I've had some previous projects open. The first time you open it, you won't see these, so you'll just need to go to Project and click on New Project. And then this is what you'll see to start out with. So what this computer icon here is showing, that's supposed to be a visualization of your computer. In order to talk to one of our I/O devices using the software, you need to have a gateway, either a USB gateway or a IP to RS-485 gateway. For this demo, we'll use the IP to 485 gateway. That one looks like this. It's actually a little device that we purchased from Grid Connect. It's called the Net 485 device. On one end here, you've got the Ethernet port. That's where your Ethernet cable plugs in. On the other end here, you've got some screw terminals. That's for the RS-485 and the power connections. So for this demo, we'll use this IP to 485 converter. You could also use a USB to 485 converter, as I mentioned before. That guy looks like this. On one end, it's got the USB style connector. On the other end, it's got screw connectors for the RS-485 network. And this is powered through the USB cable. So if you're going to use this one, you just plug the USB into your computer and then wire the 485 into the device from this side. But as I said, we'll use the Grid Connect Net 485 device for this demo. And to add that in here, you click on the computer and then go up to Device and say Add Devices. And this RS-485 here is referring to the USB to 485 converter. If you click on Gateway, this is referring to the Ethernet, which is why it's got an Ethernet plug. Ethernet to 485 gateway, which is the one we're using. So we'll call this Net 485 since that's what it shows on the device. We'll say Add. Once we've done that, it's asking us to define the IP address, and the one that we've got connected here is at 192.168.0.191. Now obviously if you're in the building, it's a local address. You can do this over the internet too, across a state or country or whatever, as long as you have access to the IP address of that converter. If it's behind a router, then obviously you'd have to do some port forwarding or open up a port or whatever to get to this device. So once we've got the gateway in there, now that's giving our computer a way to talk to the actual I/O device. And to add the I/O device, now we click on the gateway. Before we clicked on this, now we click on the gateway itself. go up to Device and hit Add Device. Now what you see here is a list of all the possible devices that MBus I/O Flash currently supports. If we go back to our web page here, I'll go to datanab.com again, go back to the home page. If we click, we can visit our online store here. If you look here under Automation Devices, we've got this category called Programmable Automation Devices, or Programmable I/O Devices. If you click on that, here's the devices that work with the MBus I/O Flash software. Every device on this page. The MBus IO12 device is what we're actually going to be using for our demo here. This guy. He's not currently shown on the website, but by the time this video is out, you'll probably see him on there as well. And that's a very nice, powerful device, and I'll go into some of those details later. But the MBus IO12, so we've clicked on the gateway here, we went to Add Device, we choose MBus IO12, and now we need to define the address. And I know that this device is at 253 right now. I'm going to hit Add Device, and now you can see that in there. So if I click on this device now, here's the program window. I can go to the identification window by clicking identification up here and hit Scan Device Status. And now what this is doing, it means when I hit this button and these lights turn green, that means that it's online and it could find the device and that the device is authorized, which means it's licensed to be programmed with MBus I/O Flash. And when you buy one of these programmable I/O devices here in this category from DataNab, it will arrive and it will always show authorized for you, so you don't have to worry about that. It's pre-licensed when we ship it out. Okay, so we've got our device. Let me show you what this IO12 actually looks like in real life. I've got one hooked up here. It's a really nice looking device, good plastics, a nice LCD display, and 4 buttons on the bottom here. This device actually has a push button on the bottom. You can use this to trigger things in your program, and it's got a light level sensor on the top. You can't see it, but it's inside these grates. An ambient light level sensor to sense the light level, so you could use that for occupancy or things like that as well, or if you're controlling dimmable ballasts or something like that, you can use that sensor for that. So that's what the device looks like that we're going to be working with here. We'll have a separate video for this device when we get it up on the website, showing you the specifics of all the I/O points and how it's designed and how you hook that up specifically. So once you've got your device here, the first thing that you usually do is you go to this Hardware Configuration tab up here and you define the I/O points. So the back plate for the IO12 looks like this, and you can see it will match up exactly to what shows up here on the screen. So you can see our analog inputs here on the left side, just like it's shown on your screen, and then we've got our digital outputs, which I can choose here, and our analog outputs on the right side. Okay, over here. These analog inputs are actually universal inputs, and one of the nice things with the MBus IO12 is that they're 12-bit inputs. On our MBus IO10 LCD G2, those are all 10-bit, but on the MBus IO12, they're 12-bit inputs. We've got the 5 relay outputs and the 4 analog outputs over here. The analog outputs can be 0 to 5 volts, 0 to 10 volts DC, or they can be milliamp current loop style outputs. So now that we've got those I/O points defined on here, if we go to our program window, I'll zoom out. You can see that over here on the left side we've got our universal inputs, and on the right side we've got our analog outputs. These 4 here are the analog outputs, and our relay outputs are our digital outputs. And now these are available since we defined them in this Hardware Configuration tab. Oops, wrong button. Since we defined them on these terminal points here, now they show up in our program window here. If I hadn't defined them, let's take out these AO points and go back to our program. Now they're not available in the program tab or the program section to use. So if I'm going to use those in my program, I have to have them defined here. Okay, these buttons up here, this is the T-int. You can see, I don't even have a program in this yet, but it's showing a room temperature because it's got a built-in thermistor input, and that's where this room temperature value is coming from. So that's what the T-int is for. The PCL is the photo sensor, the light level sensor. and we can use the value coming from that in the program. And then the MPB is the push button, which we can wire in to trigger things in our program as well. So that's what those three items are for. The MBus IO10 LCD G2 would not have this PCL or this MPB inputs because it doesn't have the push button or the photo sensor, the light sensor. But now that we've got everything in here, we can create a program. And what I'm going to do is create a program that basically just controls a relay, DO1, based off of a temperature input. So what I'll do is I'll grab a T-stat block here. I just click on it, drag it in, and drop it down. Now that it's in here, I can double click on it, and this gives me access to all the parameters in it. As I said before, the input we're going to use is the T-int. So we just click on this drop down. It shows us all the available blocks that we can wire in to the input. Choose T-int, and what this is going to do is allow us to use that current temperature value from the built-in temperature sensor and use it to control this T-stat block. The set point block, we'll get to that in a little bit. We need to create one first, so we'll use an AV for analog value block. I will double click on that. Let's call it set point. We're going to set the units to be Fahrenheit with 1 decimal place, and we'll set an initial value of 70 degrees. Alright, now that we've got a set point block in there, I can double click on my T-stat again. Now I can choose my set point. And now I'm going to set a deadband on. So what this means is when our thermistor input, our internal temperature sensor, goes above our set point value by 1 degree, it's going to turn our output on. And we'll also set a 1 degree deadband for the off side. So when it goes below by 1, it'll turn it back off. That's all for that. If we go into our internal temperature sensor block here, our T-int, I'm going to set my units to Fahrenheit, a single decimal spot, just like we did with the set point block. We can set a filter value here, 4 seconds. It'll help smooth out the reading. And you'll notice up here it's got a register number, Modbus register number 101. So for these programmable devices, when you get them, they don't have blocks already in there. You have to define all the blocks. And so in this case, they've defined the internal temperature sensor as being at Modbus register 101. When you're doing this, you want the register numbers to be 100 or above, because below 100 there are some reserve values down there. So since this is Modbus register 101, I'm going to go to my set point block and I'll set that one to Modbus register 102. And now if I have a Modbus client or a HMI or something that uses Modbus, it can get those values out of the device over the network to use in the visualization portion. We can also set our relay. Let's give that a Modbus register number of 103, and we're going to say we want to control this relay with our T-stat block. Okay, and there we now have a program. If you ever are wondering what the Modbus blocks are in your program, you can go up to Device and click Export Modbus Addresses, and then that'll give you a text file with a list of all the names of the blocks and then the Modbus addresses for each, or register numbers for each block. So right now we've got our program ready to go. The only other thing I'd like to show you before we actually download it is if we go to the Hardware Configuration tab here and click up in this portion, which corresponds, the picture is built so that this section up here is meant to be this LCD display, and we click on the display portion of it. Here's where we can define what we want to show on the display. So what I want to show is the T-int, which is my room temp value. I'll call it room temp. I'm going to make this user accessible so everyone can see it on the front of the thermostat. And I mentioned that because there's an admin mode that you can put the thermostat into. And if you do that, then you have to go into admin mode by pushing a couple buttons, which I'll show you, which will enable you to see extra parameters that maybe only admin should see. The other block I want you to be able to see or value is the set point value, and we'll just leave that at set point. We'll make this a user value too, and we'll also make this writable because we want the user to be able to change it with the buttons on the front of the thermostat. The last one I'm going to add is the ADD block, which is the address block, showing the Modbus address. I'm not going to click on this. If I click on this, everyone can see it. I'm going to keep that deselected so that only admins can view that. But I am going to make it writable so that if you're in admin mode, you can change the address using the buttons on the front. We'll set it to rotate the display every 5 seconds. We'll close this out, and now we've got a program. So if we go in here and hit scan, make sure we're still talking to it. That's good. You can see it's not in sync. That will change here now when we click on the Send Program to Device button. This is how we download the program into the device itself. Okay, and there we go. We've gotten the program downloaded. You can see everything's in sync now. Now the cool thing is if I go to my Program tab and I go into Run mode by clicking this button right here, I can put monitor tags on any of these parts of the program which show me what values I'm working with. Okay, so it shows that our temperature value from the device itself is 71.6, which is reflected if you look here. It's rotating. There you go, 71.6. It's showing our set point is 70, and you'll see the device go to 70 here. Yep. And then because of that, since our temperature value is above our set point, our relay is on. If I want to change the set point, I can use these up and down arrows right here. So I'm going to change the set point and drop it, and you can see it changing on the screen along with it. Okay. So I'm going to actually move the set point so it's above the value of the internal thermistor by a degree. So I'll move it all the way up to 72.9. And when I do that, you should see this relay over here. You should see this red light turn dark because the relay will shut off. And I can hear the relay shut off on my end too. There, it just shut off. So you can see the program's working. I can use these left and right buttons to go through the parameters, and I can use the up and down buttons to change any writable parameters as we defined by that right checkbox. I'll show it to you again here. Here's the writable ones. The set point and the address are writable. So I can use the arrow buttons to change those. Now you'll notice when I'm scaling or when I'm scrolling through the available parameters here, I'm not seeing that address block. That's because we're in user mode and we're not in admin mode. If I want to go into admin mode, I can hold these two outside buttons together, continue to hold until it says admin, then I let go. Now when I scroll through, voila, we can now see that address block too because we're in admin mode. And I can use my arrows to change the address. Okay, so if I change the address here, that means in my block identification tab I'm going to have to change it up here in order to keep talking to it. So I'll leave it the way it is now. But that's basically how you create a program in MBus I Flash. I showed you how to drag some blocks in there. Showed you how to use the hardware configuration section to define the input and output points. I showed you how to define Modbus register numbers by double clicking on the blocks. Up here we didn't put one in that one, but we did put one in the set point. I showed you, let's see, how to define what shows up on the display here and whether that should be available in user mode or not, or admin mode or also user mode, and whether or not it should be writable parameters. So that's really about all you need to know to get started with MBus I Flash. The one other thing I would show you is when you're on the identification tab here, there's a button that says normal mode. Let's say that you at home wanted to try MBus I Flash right now, but you don't have a device yet. What you can do is you can click this and change it to simulate mode. And now when we go into program and go into run, it pretends as if there's a device out there, even if there isn't. It'll say, do you want to upload? And I say okay. And you can see it didn't actually upload anything, it just went real quick. Now it's just giving you the opportunity to see how your program will work in a simulation mode. And you can see that obviously there's no input actually attached since it's a virtual device. So what we can do to see how this program is going to work is hover my mouse over here and I can type in 75 and hit enter. And boom, you can see the relay turns on here because the input's above the set point. If I want to change it down, make sure it turns off, hit 67, and there you go. So that's simulation mode. If I want to go back into normal mode, let's say I actually have an actual device now. I can do that. Now I have an actual device, and this device, we'll go back to the ID tab here and hit scan. When we went from simulate to normal, it thinks it's out of sync now. So we send the program to the device again. This is the actual device now. If we go into run mode here, now you can see we're dealing with reality because we have a real value on the temperature input. I can do the same thing here with this set point. I can hover my mouse over it, turn the set point up to 78 degrees, hit enter, it shuts the relay off. Turn it back to 70, hit enter, it turns the relay back on. But now I'm actually dealing with the real device. So hopefully this gives you guys a good example of how to get started with MBus I Flash. If you're interested in using it and testing it out, just go ahead and go to our website, datanab.com, support and downloads, main browsable document directory, MBus IO and MBus IO Flash, and then you can download the Pro or the free version. You can use it as necessary and get your hands on it and get comfortable with it. And then if you want to buy a device, just go ahead and go to our website. If you're at the main DataNab website, like I said before, click on Visit Our Online Store and go to this section here, Programmable I/O Devices. If I were you, I'd suggest using the G2 Programmable I/O. This is the MBus IO 10 LCD G2, this device, or the one that I just went over, which is the MBus IO 12 LCD, which currently isn't on this website yet, but by the time you get on there, it probably will be. The reason I'd suggest those is because they do have that LCD display, which makes it simple to test things out and make sure everything's working properly. But anyway, yeah, hopefully that helps you out. Shoot us an email if you have any questions, and we'll go from there. Thank you.